Our objective is going to be finding centroids and circumcenters. Oh, I said it wrong. Orthocenters. Finding centroids and orthocenters, and then using their characteristics. And characteristics. 4, 15, 19. Okay, so median. By now, hopefully you guys know what a median is. It's simply a line segment from the vertex to the midpoint. Oh, sorry, it's so sloppy, it's Monday. To the midpoint of its opposite side. Can we draw a picture? Let me show you. So you guys write this down. So all a median is a line segment from the vertex to the midpoint of its opposite side. So we did one here, vertex, midpoint of the opposite side, right? Okay, so it's from the vertex to the midpoint of the opposite side. That's a median. And the centroid is simply the point of intersection of all medians. Okay? It's also the center of the triangle. That's why they call it the centroid. It's also the center of the triangle, okay? It's the center of the triangle. Okay? Alright. Now, what we saw in our theorems is that it breaks it up into thirds, right? So I know that if I look at SM, that SP all the way across is going to be in terms of thirds. So I'm going to break it up into thirds. So break into 3 parts. What do I mean by 3 parts? Well, let's do this PS first. So SP, and I'm going to put a little dot right here. And again, I drew this, and I'm not any kind of an artist, so if it doesn't look right, just have to forgive me, okay? So put a dot right there, and I broke the 12 into half. So this is 6, this is 6, and this is 6. You see how it works? This is going to be 6, 6, and 6, okay? So this is the way I like to tackle it. It's so much easier if you just say, okay, well, if I break it into 3 parts, 1, 2, 3, so that's 6, 6, and that's 6, right? Now, if this is 5, that's the short part, right? If that's 5, then that'd be another 5 and another 5. So breaking it into 3 parts, simple as that. QN is 18. Well, QN is 18. Well, let me take QN and divide it into 3 parts. QN all the way across.
6, wait.
Yeah, it's 6, right? It's going to be 6, so that means this is also 6, 6, and 6, okay? Now, when I do that, it's pretty easy from there. So I can go ahead and look at this. So LP. Let's see, LP now is 10 because of the 5 and 5. Do you see LP is 10 because of the 5 and the 5? Okay. I know that SP is 6, right? I know QP is 6. And PN's all the way around, PN is 12. Okay, look at that for a second. It's all been divided up. It's all been divided up into thirds, okay? 6, 6, 6, or 6 and 12. Okay? 6, another 6, another 6, or 6 and 12. A 5, another 5, another 5, or 5 and 10, okay? Now I know also then that LR, the whole thing is 15. LR, the whole thing is 15, right? I know SM, which is the entire thing, is 18. And QN, which is the whole thing, is also 18. Now, something on our symbols as you're writing these down. Since I'm it's just a geometry thing. Since I'm describing their lengths, I don't put the little line segment over it, do I? So no line segment. If I want to talk about their lengths, how long they are, their measure. I don't put the little line on top. If I want to talk about the shape of it or the segment, then I would. Okay? If I'm talking about their length, I don't put the little line over it. Not a big deal. I would never mark you wrong for it, but it is a geometry concept. Okay? Thumbs up on that one? Does that seem pretty easy? Okay. Turn the page. Okay? All right. Altitude. Well, what do we know about an altitude? Well, okay. Max is the height, which is a very good definition. I like that definition. Let's say height. But more specifically, it's a line segment. A line segment from the vertex perpendicular to its opposite side. Okay? We did that too. I don't think I did a very good job of it. It looks pretty good here. So it's just straight down, right? Straight down 90, right? Just straight down 90, right? So it's just a line segment from the vertex perpendicular to its opposite side. Now the orthocenter is a point. So the point is the point of intersection of all altitudes. And that's what we did on a little construction. We drew all of our altitudes in. They intersect in a single point called the orthocenter, okay? And there's nothing really special about the orthocenter. It's just a definition. It's not really used for anything, but it is what it is, okay? Now, example 2. Let's do example 2 together. So if I take a look at example 2, it says, okay, graph triangle ABC. I can do that. I can handle that. -2, -1. There's A. 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. There's B. And 4. 1, 2, 3, 4. -1. There's C. Okay, I've got my triangle. I'm going to draw it in, right? Okay, how am I doing? Pretty good? Now, with altitudes, I don't care if it goes through the middle. Say it again. Altitudes don't always go through the middle. They don't have to go through the middle. Everybody got that? Mm-hmm. They do not have to go through the middle. If they do, then we've got an isosceles triangle. Okay, so first of all, the first altitude is going to be easy on graph paper. Super easy. The first altitude, watch, is right there. Because it's straight up and down, right? 90? There's my first altitude. Boom. That was easy. You guys see my blue altitude? That's got to be an altitude because it's straight down. The graph paper helps, right? Graph paper helps, go straight down. Now the next altitude is a little bit harder. And I will do my very best to help you understand the next altitude. Okay, so I'm going to turn my paper like this, okay? Now, hard concept. So all eyes are up here, even Derek. Hard concept, right? You ready? If these two lines, my green line and my pencil, right? If these two lines are going to be perpendicular, they have to have opposite slopes. Does that make sense? Okay, if my blue pencil and my green line are perpendicular, they have to have opposite slopes. So let's see. The slope here looks like it's 3, 1, 3, 1. So the slope here, this slope here is down 3 over 1. You okay with that? Down 3 over 1, down 3 over 1. So the slope of BC is down 3 over 1, right? Its opposite slope, perpendicular slope, would be up 1 over 3, right? So from AC, if I went up 1 over 3, up 1 over 3, up 1 over 3, I would get this line right here. Does it look perpendicular? Well, I'm not sure, but I think if I turn my paper, it might. Hey, it does kind of look perpendicular, doesn't it? Wow. What do you know? Now, Derek's going to save us days. You don't really have to draw the next one because we already know where the point of intersection is, right, Derek? But I'll do it anyway, okay? Now, the next altitude, right, has to be perpendicular also, okay? So I found the slope of AB. Slope of AB. Let's see. Check it out. AB. It's the hard part. So the slope of AB is, let's see, it's up 3 over 1, up 3. It's up 3 over 1. Up 3 over 1, up 3 over 1, 3 over 1. So its opposite slope would be down 1 over 3, right? Its opposite slope would be down 1 over 3. So I'm going to do that. I'm going to go, okay, I can handle that. I'm going to go, let's see, down 1 over 3. Down 1 over 3. Oh, from here, sorry. Down 1 over 3, 1, 2, 3. Down, but it's going the wrong direction, so let's go 1, 3 this way, 1, 3 this way, and sure enough, it does intersect in that point right there. Okay, there's my orthocenter. My orthocenter is at the point of intersection, at the point. So my orthocenter is at the point 1, 0. Okay, that's a little bit harder, isn't it? It's a little bit harder. Okay. Now, homework's got to